Should we have another one?
No. No.
Does anybody have two of these by accident?
No, don't think so.
I need 29 copies.
Can I go make the other copy?
No. I can't send you to the printer. All right, fold this one for me. Okay. If you put it so the problems are facing you, the left flap folds in and the right flap folds in. Okay. If you're confused, Shelby and Elijah already know how to do it. You can look at theirs. And then you're going to cut along the dotted lines.
Can I see yours, Shelby? You.
Hold the side,
It's
into the middle line, and then you cut them up.
I mean, it's I'm having a slow day.
Yes. Many attempts.
What guys have found intelligent before? Shut up. Shut up.
You do realize you could have set up for that equality.
Shut up.
If you
Kid,
put quotes
you
on
know
it.
that he already did it, so like, you know that he really suspected it.
Seventh grade sleep there. You didn't even show, right?
That's it. You wanted me to have the whole day. That's it. So you just got.
Jason.
All right. There we go.
It's not even today. Right. What is the purpose?
All this conversation
We're gonna get you demonetized because we said a bunch of bad words. Last year, shut up, everybody.
Look, yes, I did.
Brandon, plant your butt, please.
Sorry, I'm trying to send it.
All right. So you should have folded the left side into the center like so. The right side into the center like so. And cut yourself some flaps along those dotted lines. Okay. You should have 3 flaps on each side. Yeah, the senior class president's supposed to come up with it.
Who's the senior class president this year?
Honestly, I don't know.
Isn't it Molly?
Yes, maybe. Maybe. I don't keep up with student government. That's Miss Porter and Mr. Johnson that does student government.
You get it? Because like every
Like, the senior class president makes the. We glue it down on page 74.
Okay, this will glue down on page 74. I'm gonna wait until I fill mine out before I glue it in. You can do whatever your little heart desires. Does not bother me.
I mean, they do a lot.
Okay. So the first thing we need to cover before we do. I should not hear your voices when I am talking unless I'm addressing you for some reason. Okay. My voice is actually starting to go now, which is fantastic. Okay, the first thing we have to do before we even do anything with solving these, simplifying them, is we need to be able to go from a square root to rational exponents. So we've already done x squared. Okay, you know that 2 is an exponent. To make it rational, it would have to be a fraction. So now we're going to deal with exponents, but instead of them being whole numbers, they're now going to be fractions.
Unfavored.
Okay, so the rules still are the same though. If I'm multiplying x's with exponents, we still add them. If I'm dividing with exponents, I still subtract them. It doesn't change except for they're now fractions, which y'all hate, but we'll live with it, right? All right, so the first thing I need to show you is if I give you something raised to a fraction, you can write that as a radical, which means I can now use the square root symbol. Okay, radical, square root symbol, same thing. Okay, so if I have some value raised to the m over n, so m is your numerator, n is your denominator, m then becomes your exponent. Okay, so your m in the top stays with your variable or the number or whatever. Okay, the n then becomes the root. Okay, so what I mean by that, this would become 9. Okay, the number on the top becomes your exponent. So it's 9 to the first power. And your bottom, your denominator of that fraction becomes your root. So this is the square root because that's a 2. Notice, I didn't write the 2. Okay, when it's square root, it's just a square root. Hold on, breathe. We will get there, I promise. Okay, look at number 2 then. Okay, number 2, it's 8. What's your exponent going to be? The 2. It's the number on the top, so it's 8 to the second power. This time, my root is a 3. It's the cubed root. Notice, I had to write the 3 there to tell me that it's the cubed root. The only time I do not write a number is if it's a square root. Okay, square root, you will never see a 2. You'll just see the symbol. If it's cubed root or 4th root or 17th root, you will see a little number on the outside. We're going to talk about what that number is in a little bit. Okay, so then number 3, this would be x to the third. And what root is this? The 5th root. So we have to put a little 5. Okay?
Is that it?
That's it for right now. Okay? We're not doing anything with that other than going from, if I have a fraction, what does that look like as a radical? Okay? If you scoot to the other side, this time I need to go from the square root or the cubed root or the 5th root, whatever, and we're going to write it as a fraction now in an exponent. So we're working backwards from what we just did. So this one becomes 13. It's to the first. Okay, there's no exponent on the inside. So my numerator's a 1. What should my denominator be? 5. Okay, your denominator's the root and your exponent is the numerator. So number 5, this would be 25 to the 1/3. Fantastic. Okay, this one, ooh, 5 halves, yes. Okay, your exponent's a 5.
Oh, and there's a square root. Oh my
And there's a square root, which makes your denominator a 2. Super smart.
So anytime I have parentheses in the square root,
It's still your exponent. It's no different if it's on the inside or the outside. Okay? Yes, sir.
Good? Okay. Question. Okay. All right. So now we're going to get into some of the rules. Product rule with exponents. Okay. So if I did something like, let me go back. Let me take you back old school a little bit here. If I did, bless you, x squared times x to the 5th, what's my answer? X to the 7th. Okay. You add your exponents. The product rule does not change when I make my exponents rational. We still add them. So this becomes x. What do I get when I take 1/5 plus 3/5? 4/5. Okay. Huh? Again, I can take this and write it as a radical instead of in exponent form. So this can be written as x to the 4th and the 5th root. Okay. It's the same thing. Okay. So both of those answers mean the same thing. I don't know what your tests on your final will give you, whether it'll be in rational exponent or in radical form. So you need to remember how to go back and forth. Okay. This second one, before you do anything, make it into rational exponents first. So this first one should be x to the what? 1/4 times x to the 2/3. Okay. X to the 1/4 times x to the 2/3. Okay. So this becomes x. Should we go old school with adding fractions? Oh my gosh. Okay. That's fine. Let's do old school. So 1/4 plus 2/3. Before I can add, I must have a common denominator, which is going to be what? 12. Okay, hold on, Rebecca. What did you say the first one should be? 3/12. Remember, I have to multiply 4 by 3 to get me to 12. What I do to the bottom, I have to do to the top. So that makes it 3/12. And 8/12. I have to multiply 3 by 4 to get to 12. So I have to multiply 2 by 4. Okay. Rebecca's on it today. Okay. So when I finally add them together, it's x to the 11/12. What does that look like in radical form? Okay. So it's the 12th root. That's how we say that. The 12th root of x to the 11th. That's the 12th root of x to the 11th. So again, these two mean the same exact thing. One's just in radical form and one is in rational exponent form. Okay, so when I multiply, we added the exponents. On the other side, it's the quotient rule, which means what? Divide. Good, Cody. Okay, so when I divide, we're going to subtract my exponents. Okay, so this one becomes x, and we're taking 7/10 minus 6/10. 1/10. So this can also be written as the 10th root of x, because you do not need to write the power of 1. Remember, it's an unwritten thing. Just like square root, I don't need to write the square on the outside of the square root. It's an unwritten rule in math. Okay? On the other side, again, make it into rational exponent form first. So my top one should be x to the 5/6. And the bottom should be x to the 2/6. So again, we subtract our exponents. 5/6 minus 2, 6. Whoops, sorry. Let me move that over. So x equals 3, 6, which reduces down to 1/2. Okay, good. Please reduce if you can. So they realized that 5, 6 minus 2, 6 is 3, 6 and reduced it to 1/2. So again, I can also write this as the square root of x. X to the 1/2 is the same thing as the square root of x.
X what? X over what?
X to the 1/2.
X to the 1/2 power is the same thing as the square root of x. Because your exponent's a 1. So I don't have to write that.
Oh, 3, 6.
Yeah. Sorry, I went to put the equal. I went to put the equal sign before I put the fraction there. So it kind of looks like a, I don't even know. Yeah. So I apologize for that. That is 3, 6. Please do not let that confuse you.
You're right. Away of 6 of each does not.
Yeah, so true. Okay, 2 more rules. Power rule. Okay, my power rule. If I have a to the m raised to the n, so again, if I had something like x to the 2nd raised to the 3rd, what's x to the 2nd raised to the 3rd? X to the 6th. Okay, so you multiply your exponents when I have a power to a power. So we're going to do the same thing here. So, we're on the bottom right, or bottom left. Sorry, bottom left. Sorry. Okay, so I'm going to take my fractions and I'm going to multiply them. So we've got 3/5 times 1/2. So when we multiply straight across the top, 3 times 1 is? 5 times 2 is? Can I reduce? No, you're finished. Okay. Again, I can rewrite this as the 10th root of x cubed. That's it. Okay. So again, your rules aren't changing. And that's what people don't seem to grasp. They see fractions and they're like, oh, we've got 17 new rules. No, the rules don't change. We've just now created these fractions that you all hate. Okay. So the next one, this becomes x, and we're multiplying 3/4 and 2/3. So this becomes 6 over 12, which you've already said is x to the 1/2. And again, I can write that as the square root of x.
How come we went from quadratics to this? Because quadratics was a lot.
This is harder. We've got to start out with a lot of basics before we get hardcore into square roots. I'm sorry. Okay, last one, negative and zero rules. Okay, remember, I can never leave an exponent as negative. My exponent always has to be positive. So, if my exponent is negative, we need to flip-flop it to make it positive. So what I mean by that is how we get rid of that negative 3/2. I take the inside of this and flip it. It becomes 9/4. And it's now raised to the positive 3/2.
Where's mine?
She's got some food. She's alive. I got 2 breakfast.
Oh, isn't your sister sweet?
That's Starbucks.
Yeah, I'm not going to
Oh,
that
no,
crap.
it's too expensive.
It's Starbucks. But it don't like it, girl.
Girl, I asked for the smallest one and they gave me a venti. I was like, I don't need that much.
That's why I was missing one. Because we had one already. Yes.
I'm special.
Yeah,
Of course you're special.
What is it?
Okay, no offense, but we're not eating that right now.
Yeah, I know.
Yeah, what is it?
All right. So, guys, we cannot get off track just because Lydia has not told us. We love her.
Yeah, if you're one of the videos, don't you make Lydia?
Right, you've become YouTube famous because you walked in right in the middle of the video.
Oh.
And everybody's like, Lydia!
About 10 people are gonna know your name.
Okay? All right, so,
actually,
again, to change it, we just make it positive by doing, what do they call that when they switch the fraction?
Reciprocal.
Oh, yes! Okay? All right. The last thing, the last rule. If I raise anything at all to the 0 power, the answer is 1. Every time, no matter what it is. I can give you, hold on. I can give you this. I can give you 1/2 x to the 7th, y to the 17th, z to the 2nd, and I can raise that entire thing to 0. If the entire thing is raised to 0, your final answer is 1. Done.
you don't have to work it out.
You don't have to do nothing.
Wait, what if there's a number outside of parentheses?
Okay, so you want to know if I had, like, if 1/2 was out here and this was raised to the,
Yeah.
okay? So, Jalecia just asked, well, what if that 1/2's on the outside? So, this entire thing becomes 1. Your 1/2 is not affected, and this entire thing becomes 1, which means my final answer is 1/2.
So anytime an equation is like that, right? Your answer says basically the one outside, or if
Yep.
nothing outside is 0.
Yep.
Or 1.
Yep, every time. Okay, so x to the 3/4, all raised to the 0 power, is 1. Okay. If you have not glued this in yet, this will glue in on page 74.
We don't do nothing else to number 13. Miss Smith.
Huh?
Do we not do anything else to number 13?
To number 13.
Number 13.
The one where it was just this one.
Oh, no, you're done with that one.
Oh my God, it's kind of cool.
Yeah.
Yes. Okay. Good question. Let me address that here in a second. Let me get this glued in, and we'll address that.
It's on 74. We're already in the
Debatable
70s.
topic.
Yes. Okay, guys, give me a second. Let me refocus you all here for a minute. Okay. Elijah said, how does flipping my fraction change it from a negative to a positive? So if I ended up with something like x to the -2, in order to make that positive, it had to go into the denominator. Okay. In order to change an exponent, or if I had like 1 over x to the -3rd, in order to make either one of those positive, they have to move either from the top of the fraction to the bottom or the bottom to the top. So if I create this as a fraction, if I have x, what's in the denominator? 1. So to make this positive, it would go 1 over x squared. Okay. If it starts negative in the bottom to make it positive, it goes to the top. So this becomes x cubed.
So what if your exponent is a positive? Would it change to a negative?
No. If you would move it, yes. So if I started out with like x to the 7, and if I moved it to the bottom, 1 over x, that would become x to the -7.
So numbers don't change, exponents change.
The
signs.
exponents will change signs, yes.
What I was asking, how does changing the 4 and 9, changing the 9 to the 4th place?
But
how
look,
did that-
look what's happening here. If I move the X to the bottom and the 1 to the top, all you did was flip it to get here. It's the reciprocal. Because I can write this like this and it's the same thing. Okay, does that make sense a little bit?
That's what I was asking.
Yeah.
I wonder why you
Yeah.
flip the fraction.
It's, you can write it on the outside and it doesn't change it. All right, friends.
I don't wanna look at a brick wall after I do this.
You don't want to ever look at a brick wall again?
What?
All right. So that's 74.
Lord.
Okay. On page 75. Ladies and gentlemen, just because I stopped to discuss something does not mean that's free time. Please stop. Focus. Okay? All right. On page 75. If you would like to trim this up, because I don't like all the extra hullabaloo on it, okay, you need to glue this in at the top of page 75, the prime numbers below 100, okay, because it need to talk about prime factorization. We need to talk about prime factorization.
Smith, were you a math quiz growing up? You aced all your math classes?
Actually, I lied. Do not glue that in on 75. Did anybody glue in yet?
No.
Okay. Do not glue that in on 75. We're going to glue that in at the top of 76. Okay. Glue it at the top of 76. Okay. I gave this to you as a reference. What makes a number prime?
It can't be divided.
It can't be divided by anything but
So
1 and itself.
17.
Okay, so these are all of your prime numbers that are below 100. Please glue that in at the top of 76. On the other page, we're going to glue in this piece sideways, but it says prime factorization, that little hash sheet that you have. Yes.
At what grade do you think we were supposed to learn what prime numbers
I'm pretty sure, yeah, that's some kind of elementary grade.
are? Yeah, that's why I never fucking knew what it was.
I don't remember.
One of them was maternity leave, so we had subs for most of my classes.
Do you remember doing the factor tree where like you start at 26 and you fact? That's what this is. That's what this is. That's what we're about to do. But I'm going to teach you my way to do it because I hate factor trees.
When do we do stem?
We don't do stem and leaf plot in here.
What grade is that? I think I switched schools during that.
Stem and leaf plot should have already been done.
And what page do we do?
Okay.
Oh, okay.
Okay. So 75 is going to be this half sheet. Okay. Yes, I'm going to teach you the birthday cake method.
Is it fun?
I like the name of that.
Why? Because it's cake.
I don't like cake.
I don't even like it.
I like ice cream cake.
Mm.
I don't like regular.
I've grown.
I worked at Dairy Queen for 10 years and ate ice cream cake.
I like it.
Jelly bars.
Do you have
Cluster bars.
Who works at Dairy Queen for 10 years?
Wait, the vanilla ice cream? Yeah.
Oh, no, they don't.
All right, guys.
What?
Yes. Hey,
I just did.
stop, please. Okay, focus up here, friends. Okay, so I'm going to take you back old school, which is probably how you were taught how to factor. And then I'm going to show you my way to factor. I personally do not care which way you choose. Okay, some of you will like my way because it's more organized. Some of you like the chaos of the factor tree where it's like boom, 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 boom. Okay, I can't. My mind just won't wrap around it anymore. When I taught 6th grade back in Pennsylvania, somebody taught me the birthday cake method, and I've never factored any other way ever since. Okay.
Yeah, what part?
I live like 45 minutes outside of Pittsburgh.
You know where Pottstown is?
Yes.
That's where my sister lives. I was there.
My cousin lives in Pottstown.
Harrisburg is
Jeremiah heard that. He just started staring.
All right, guys. So when we factor using the factor tree method, which most of you are used to, we start by writing the given number. So we need to find the prime factorization of 120. So you always would write 120. You're then going to branch off, and you're going to pick two numbers that multiply together to give us 120. So give me two numbers. 60 and 2.
30.
Okay. 60 and 2. Okay. So 2 is prime. So I want you to circle it.
Oh my God, I know what we're doing.
Okay.
I know.
So we need to keep factoring until all of my numbers are prime. So 2 is prime. What does 60 break down into? 30 and 2. 2 is prime. 30.
15 and 2.
That's it.
No, it's not.
2 is prime.
3 and 5.
3 and 5.
Now that's it.
Now that's it, because 5 is prime and 3 is prime. So if I write this as prime factorization, this is 2
Is it better than I don't remember?
times 2 times 2 times 3 times 5. Okay? I can also write this as 2 to the third power times 3 times 5, because I have 3 2s. So I can write that as 2 to the third power. That's the same thing as 2 times 2 times 2 times 3 times 5.
Oh my God, I can.
Okay. So if you like the factor tree, which takes up a lot of room because it branches out and down and everywhere, okay, use the factor tree.
I just want to be able to write it all down.
You're not missing anything. That's all I wrote
That
was
is
120. Yeah,
okay.
120 down. Everything else above it is just the steps to it. Okay. All right.
Thank you.
So the only thing with my method, when you do the birthday cake method, the numbers that you pull out or divide by have to be prime. You cannot divide by anything that is not prime, which is why I gave you that cheat sheet with all the prime numbers that are below 100. Okay? And call it your cheat sheet.
What about the one above?
We're not we're not going that high, friends. No.
Maybe I want to go.
We're doing the same thing. So guess what? We should end up with the same answer. Okay? All right. So we're going to draw yourself a layer of cake. So here it is. Here's your cake. You remember when we did greatest common factor?
No.
And we did that? That's kind of what this is. Okay? So there's my layer of cake. There's my first layer. Give me a prime number that divides into 120. 2. So that goes on the outside. You could have done 3. You're right. 2, which means I'm left with 60.
Oh my God.
Okay? Kate says 3. 3 is a prime number that divides into 60. If I divide it into 60, I'm left with 20. Give me a prime number that goes into 20.
How about 5?
5.
Wow.
That leaves me with
That's crazy sauce.
4. Give me a prime number that divides into 4. 2. That leaves me with 2. Give me a prime number that goes into 2. 1 is not prime.
Wait,
2.
That's upside down.
Okay.
Right. it came
So,
upside down.
stop. Hold on. So, when you're finally at 1, you're finished. Okay. Why is this called a cake? Well, let's see. If I flip this upside down, it looks like a tiered cake, and this is your candle.
What is your candle?
Why do you only have 1 candle?
Because I'm number 1,
Is that
and it
just
can't be
smash
number
cake?
2.
No, that's just smash cake, isn't it?
Yeah.
That's smash cake. Because you're only 1 year old. So you gotta make something big so you just smash
Okay.
it.
So, okay. All right. Please stop. Okay. So, all of your prime numbers that you put down the side is your prime factorization. If you notice, I've got 1, 2, 3 2s. So that's 2 times 2 times 2. I've got 1, 3. So that's times 3. And I got 1, 5 times 5. Again, this can be written as 2 to the 3rd times 3 times 5. Okay.
Who taught you this?
Miss DeLuca. It's who I long-term subbed for her in the 6th grade when she went on maternity leave.
You have some disrespectful kids.
No, I love that middle school. That was the best middle school I've ever worked at in my life.
What about
I've never been to your middle school.
Oh, no, middle school.
I said that's the best middle school I've ever worked at in my life. I didn't say anything about high school.
What's the best
I love working here.
Why?
How much did they have to pay you to work here?
You
How much
all.
did they pay you to
I will tell you that we stay in teaching because of our children. Because we love you guys.
That's what I thought. No, I don't get paid.
Don't do this shit.
All right.
That's why I stay at my job because I like my customers. Because if I didn't like my customers,
That's exactly
I wouldn't
it.
be here.
Okay.
No, I don't like my boss.
So the last thing we need to fold and do today is this last sheet. Okay. So I want you to put it so the blank side is facing you. Okay. This is slightly complicated. So I need you to really pay attention here. Okay. Everybody with me. Blank page facing you. You got this. Ooh. We're getting ready for that game tonight. Ooh.
What did you just do?
I don't know.
So sad about it.
Okay.
You gotta do that.
Oh, God. All right. So please fold this in half, hot dog style.
hot dogs? That
Hot dog.
All the way because then I'm
Yeah.
y'all need to stop.
Huh?
Right.
Why? We making you hungry?
We ain't got lunch. I actually got lunch to go.
I have to.
Go get some grab and
Anybody
go.
else's? No, because then I go.
Grab and go is disgusting.
Yeah, it's disgusting.
I'm sorry.
We grow up for nothing. Disgusting.
And also the line is ridiculous.
Exactly.
Chill. Okay. All right. Once you fold it in half, hot dog style, I then want you to fold it in half again.
Hamburger?
Okay. Hamburger style.
Which way?
Oh, it is perfect.
Okay. You want
Mouth is watering.
prime factorization facing you like this. Okay. If you can run your fingernails or the scissors or something, you want to make this kind of like as crisp as possible. It makes it easier to fold. Okay. You know, girls with their long fingernails, they can do it with their fingernails. You know, if you got short fingernails, you might need to run the scissors up it. So if you take your scissors and kind of go like this, it'll crisp it up for you. Okay. We're going to fold it in half one more time. So it's the prime factorization again is still facing you. Okay. So fold it in half one more time so it looks like this. We're not done yet. I told you this is complicated. But we got this.
We've got like 10 minutes, so you better.
Listen, boy, we got this.
Listen, boy, we got it.
How do you know that, by the way?
What?
2018, you can't assume that.
You
I
said
said what?
You said
Oh, wait.
Oh, I'm sorry. Listen, we got this.
That was worse.
Okay. All right. Open it all back up. Oh man, we just did all that folding for nothing. Okay.
I will forget how to fold it.
Open it all back up. Okay. Once you've opened it up, again, put that blank side facing you and fold it in half, hamburger style now.
Right. Right. You gonna break the thing.
Oh.
I
Oh.
was never.
Hamburger style.
Yes.
I was never taught
Hamburger?
Right.
This is hamburger. So your page should look like this right now. Hamburger style. Okay. All right. All right. You ready for this? You ready for this? Here we go.
What kinds of crazy kids do stuff?
Okay. So we're going to take our scissors now. Please watch what I do before you cut this wrong, because if you cut it wrong, it's not going to fold right. Okay. So
Oh.
I'm just waiting for everybody to pay attention so nobody messes this up, because I'm not printing you another one. You're just going to have to deal with it. Okay. All right. Take your scissors from this side where it's folded and you can't open it. Okay. This side, you're going to take your scissors. You're going to cut along your fold to the intersection right here. Okay. You're only cutting this half. Straight to that intersection. Okay. Yes. So if you would open it up when you're done, you've got this gaping hole in the middle. It's like nom, 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 nom. It's going to eat you. Nom, 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 nom. I really think I'd be awesome at elementary, but elementary kids drive me crazy. I couldn't do it. I couldn't. Okay. All right. You ready?
Yeah.
So once you get it cut, I want you to fold it back hamburger or hot dog style and put it on your desk like this. So you've got that big old hole in it.
I messed up.
Rebecca's got it. Okay. So what you're going to do now, listen, stop.
Oh my goodness, I see it.
Again, stop. Are we done? Okay. So once you have it in front of you with that big old hole, you're going to push it and fold it into a booklet.
What? It doesn't fold that way.
Yes, it does. So grab your ends with your diamond in the middle, push it in, and fold it over.
That's bad.
That's advanced paper folding.
She got us through a hard
Origami in math class. That's right.
No, you have this thing.
So now you've got a book on practicing prime factorization. Mini book.
I don't think it's like voted right. It's like
If you didn't make your edges crisp enough, it's hard to get it to.
no, I mean like it's not. My edges aren't like aligned up.
All right. Here we go. Everybody get their booklets. Good. Okay. You're going to open up your booklet. And here's your examples. So, again, I don't care if you choose to do the factor tree. Does anybody in here like love the factor tree? You're going to stick with the factor tree.
I might switch it up.
Listen, y'all, by all means, if you want to do the factor tree, go for it. Okay.
No.
Yes, if you want to. As long as you're not gluing any problems, you're good. Yeah.
The kids are opening it up now. You can see one goes down and
What do you mean close what down? It needs to be open so you can get to all the problems on the inside. Okay. All right. So find the prime factorization of 48. Again, if you're all about the factor tree, use the factor tree. Those of you that want to do the birthday cake method, that's what I'm going to stick with because that's what my mind can wrap around here. Okay. So 48. Give me a prime number that goes into 48. 3 does go into it. We can do 3.
16.
Does anybody know the trick on how to tell whether a number is divisible by 3?
Nope, you add the numbers up and.
Aha! Somebody just said it.
Okay.
If you add it up.
It's like the
So, what's 4 plus 8?
12.
12. Is 12 divisible by 3?
Yes.
Then 48 is divisible by 3.
Oh. Yeah.
So if I give you something like 132, what's 1 plus 3 plus 2? 6. If 6 is divisible by 3, then that number is divisible by 3. Okay? So, when I divide 48 by 3, I get what? 16. Give me a prime number that goes into 16. 2. And that leaves me with 8. Good. 2 and 4. 2 and 2. 2 and 1. There's your candle. Okay. So your prime factorization is 2 times 2 times 2 times 2 times 3. Or 2 to the 4th power times 3.
Wait, is this the hard part you were talking about?
Will we solve that?
It's not hard. I was just
Tomorrow we're gonna simplify, and then we're gonna start adding and subtracting radicals, multiplying radicals, dividing radicals. That's when it starts to get.
What's the hardest point? Like,
Because you know how like when you add and subtract with like x's, you've got to have your like terms.
yeah.
You've got to have the same thing with radicals, and that becomes difficult. Yes, ma'am.
Should this be on 76 or 70?
We're gonna glue it right underneath that prime factorization numbers on page. What was that? 76.
Yeah.
Okay.
All
right.
I thought it was 6.
Find the prime factorization of 38 this time. What is a prime? Oh, okay. Elisha's going big here. Elisha says 19.
He's right.
I would have went with 2 and gotten 19. Okay, so he went 19 and got 2. So then 2 and 1.
That eliminates so much.
So that's 2 times 19. The bigger you can get your prime numbers, the better off you are because it makes it shorter. Okay. So this one's pretty short. Okay?
Yeah, thanks.
Your homework for this evening is to finish this booklet.
She said no.
So you got 1, 2, 3, 4. And guess what? You still have 7 minutes. So I suggest you continue working until I tell you to pack up.
Let me stretch my neck.
Somebody post